Electronic Measurements and Instrumentation. The publication is Dhanpatra. Next book is Electronic Instruments and Instrumentation Technology. Author is M.M.S. Anand. Publication is PHI. These are course outcomes. First course outcome is identification of various instruments and measurement through it. Next, analyze performance characteristics of electronic instrument, then analyze characteristics of different transducers, and then verify truth table of A to D and D to A converter and its types. The assessment tools are Midsem Exam 1, Midsem Exam 2, quizzes, university exam, and indirect assessment. Objective: at the end of this lecture, the students will be able to explain the basic construction and working principle of de-Arsenal meter movement and the conversion of galvanometer into ammeter. The galvanometer is de-Arsenal meter. The de-Arsenal meter movement, the moving coil galvanometer, this is also called de-Arsenal meter movement, and it is constructed by Jacques de-Arsenal. This is also called permanent magnet moving coil meter, PMMC. This is also called simple galvanometer. So it can be used to indicate the value of DC and AC quantity. The basic construction of PMMC is shown here. N is showing the north pole of the magnet and S is showing the south pole of the magnet. A former is placed in between this permanent magnet. On this former, coil is wounded, and on the coil, a pointer is attached. This is the pointer, and this is the scale. The wires are taken out from the coil. The permanent magnet, the north pole and south pole are the poles of the permanent magnet. This is creating magnetic field. When the current starts flowing through the coil, electric field is also generated. So the electric field and the magnetic field will be interacted with each other, and because of this, a force is generated and the coil starts moving. And since this pointer is connected to the coil, so the pointer also starts moving. The amount of rotation of the coil is proportional to the amount of the current flows through the coil. So the amount of movement of this pointer is directly proportional to the amount of the current flowing through the coil. The meter requires very low current for a full scale deflection. This is approximately 50 microampere. And so this consumes very low power, approximately 25 to 200 microwatt. So this is the basic construction of the de-Arsenal meter or the galvanometer. This complete construction is denoted by a simple circle with an arrow, and it's a meter resistance denoted by RM. RM is showing the resistance of the meter or resistance of the de-Arsenal movement or resistance of the galvanometer. IM is the current flowing through this galvanometer. So instead of drawing this complete diagram again and again, we will draw this diagram now for the galvanometer. So this PMMC galvanometer, this constitutes the basic movement of a DC ammeter. The coil winding of a basic movement is very small and very light also. So it can carry only very small amount of current. So this can show the current of approximately 50 microampere only. But if we want to measure more current, then we have to do some arrangements. So this galvanometer can be converted into an ammeter by connecting a low value of the resistance in parallel of this galvanometers. As shown here, you can see here, this is the galvanometer and a shunt resistance is connected in parallel of this meter. This low resistance is called shunt resistance, denoted by RSH. The scale is now calibrated in amperes, and the range of the ammeter depends on the values of the shunt resistance. A low value of resistance, this low value of shunt resistance is used in DC ammeter to measure the large current. So you can see here this RM is the internal resistance of the movement. RSH is the shunt resistance. ISH is the shunt current. IM is the current flowing through the galvanometer or full scale deflection current of the galvanometer, and I is the total current, or you can say the full scale current of the ammeter. This current is equal to shunt resistance, shunt current and meter current. This I is having, this I is flowing from this path, and this is having a parallel path after this. So this total current I is divided into ISH and IM. So I is equal to ISH plus IM. That is, total current is equal to shunt current plus meter current. So if we want to make the galvanometer, if we want to convert the galvanometer into high range ammeter, so consider for this, if I'm saying this galvanometer can measure 1 ampere current, but if I wish to measure the 10 ampere current from the same device, then a shunt resistance is required to connect in parallel of this meter resistance or in parallel of this meter. And the value of this shunt current should be such that it can flow the 9 ampere and only 1 ampere can flow through this. So with the help of this, the total 10 ampere current can be flow, and then calibrate the scale as per the 10 ampere current instead of 1 ampere current. So such an arrangement converts the galvanometer into high range ammeter. So these are some relations for the shunt resistance. The shunt resistance value can be calculated if I can see here. I can see here the voltage drop across this resistance or this meter is equal to IM into RM, V equal to IR. So the I is IM, R is RM here. So the voltage drop across this meter is IM multiplied by RM. Now the voltage drop across this shunt resistance is RSH multiplied by ISH. The voltage drop across this and the voltage drop across this will be equal since these are in parallel. So I can write ISH into RSH, that is this ISH into RSH, voltage drop across this equal to the voltage drop across this meter resistance, which is equal to IM into RM. So I can calculate the value of shunt resistance from here. This is equal to IM RM upon ISH. The value of ISH is equal to how much? I is equal to ISH plus IM. So I can write ISH equal to I minus IM. ISH equal to I minus IM. So the shunt resistance is equal to IM RM upon ISH. ISH is equal to I minus IM. So with the help of this relation, the shunt value of resistance or the shunt resistance value can be calculated. Let us numerical. We take a numerical 1 milliampere meter movement with an internal resistance of 100 ohm is to be converted into 0 to 100 milliampere. Calculate the value of shunt resistance required. So we can apply the formula shunt resistance equal to IM RM upon I minus IM. So what is the value of RM? The value of internal resistance of the meter is 100 ohm. So RM equal to 100 ohm. What is the value of shunt resistance? Calculate the value of shunt resistance. That is, it is required to calculate. So RSH is equal to question mark. We have to calculate this. Now see the value of meter current. It is equal to how much? You can see a 1 milliampere meter movement. That is, meter allows 1 milliampere current only. So I am equal to 1 milliampere. And in this numerical, it is required to convert this 1 milliampere meter into 100 milliampere ammeter. So the total range which we want to show through the ammeter is 100 milliampere. So current I is 100 milliampere, IM is 1 milliampere. Here also 1 milliampere and RM equal to 100. So the answer is 1.01 ohms. Thank you. This completes this lecture.